Hello! This will be a demonstration of Proposition 12 from Book 7 of Euclid's Elements, which says that if there be any number of numbers, as we please, in proportion, then as one antecedent is to one consequent, so all the antecedents, that is the sum of the antecedents, shall be to all the consequents, that is the sum of the consequents. We're just going to deal with the simplest case of four numbers in proportion, so that the number A is to the number B, just as the number C is to the number D. And what we're going to prove is that the number A, which is one of the antecedents, is to the number B, which is one of the consequents, that the number A plus the number C, which is the sum of the antecedents, is to the number B plus the number D, which is the sum of the consequents. Now, the number A being to the number B, just as the number C is to the number D, it then follows from the definition of proportionality, which is definition 720, that the number A is the same part or parts of the number B that the number C is of the number D. Just like the previous proposition, we're assuming that the number A is less than the number B, and that likewise the number C is less than the number D, but this proposition works just as well if the number A is greater than the number B. You'll just have to invert the proportion, which you can just take as just a property of numbers. Okay, so the number A is the same part or parts of the number B that the number C is of the number D. Now, this being the case, then by proposition 7.5 or 7.6, depending on if the number A is a part or parts of the number B respectively, we can then say that the number A is the same part or parts of the number B that the number A plus the number C is of the number B plus the number D respectively. Again, that's proposition 7.5 if the number A happens to be a part of the number B, and 7.6 if the number A happens to be parts of the number B. Now, this being the case that the number A is the same part or parts of the number B that the number A plus the number C is of the number B plus the number D, it then follows from the definition of proportionality that if a first number is the same parts of a second, that a third is of a fourth, follows that the four numbers are proportional, so that we can say that the number A is to the number B, just as the number A plus the number C is to the number B plus the number D. And this is precisely what we set out to prove, which means we are done with the proposition, therefore, etc., Q, E, D. Now, an example of this would be that 6 is to 8, just as 9 is to 12, and just as 15 is to 20. What this proposition tells us is that if we add all the antecedents together and add all the consequents together, the sum of the antecedents will have the same ratio to the sum of the consequents that one of the antecedents has to one of the consequents. So we're just going to take the simplest one. 6 is to 8, just as the antecedents here being 6, 9, 15. So we're going to add those up. Is to the sum of the consequents. The consequents here are 8, 12, 20. So we're going to add those up. Now, 6 plus 9 is 15. 15 plus 15 is obviously 30. 8 plus 12 is 20. 20 plus 20 is 40. And this is going to be in the same ratio as 6 to 8. And this is obviously the case. Namely, that 6 is 3 1/4 parts of 8. And likewise, that 30 is 3 1/4 parts of 40. Finally, it should be noted that this is the number equivalent to proposition 5.12, which was about magnitudes. Again, because numbers are not magnitudes, we cannot assume that the properties of magnitudes and the properties of proportions of magnitudes will obviously carry over to proportions of numbers. That's all I've got to say about this proposition, so I'll end the video here and move on to proposition 7.13.